Today we are jumping right into the trenches. We're going to explore some real-world production fires to pull out some absolutely critical lessons on observability. We're talking about what happens when everything goes sideways, and how having the right kind of visibility can be the difference between panic and precision.
Oh man, every single engineer knows this feeling, right? That horrible, jarring alert that rips you out of a deep sleep. The system is down, the customers are angry, and all the pressure is on you. But the biggest, scariest question is always the same. Where in the world do you even start looking? And that, my friends, is where observability comes in.
Okay, let's dive into our first story. We're going to call this one the silent killer. It's a classic case of how one single, slow dependency can quietly bring an entire system to its knees in a massive, cascading slowdown.
You have to imagine the frustration here. Support tickets are flooding in, customers are furious, the site is basically unusable. But the team? They're staring at their main dashboard and everything looks perfect. CPU is fine, memory is stable, no error spikes. The system thinks it's healthy, but the reality for the user is something totally different.
And this slide just captures that chaos perfectly. On the left, you see the team just guessing, right? Throwing darts in the dark. Is it the database, the network, a weird memory leak? But then, look at the right. That's the signal that cut through all the noise. P99 latency on their calls to an external API. That one metric was the key to everything.
So what even is P99 latency? Well, your average response time might look totally fine, but P99 tells you what your unluckiest 1% of users are actually going through. It's like a magnifying glass for the worst-case scenario. And in this story, it showed that a third-party service was timing out just often enough to create a massive bottleneck that rippled through their entire application.
All right, let's move on to our next war story. This one's all about deployment chaos. It's a perfect example of what happens when you're flying completely blind because you don't have the right kind of logging in place.
So just look at this timeline of events. At 2 p.m., a new feature gets deployed. Just 5 minutes later, the alerts for server errors, those dreaded 5x errors, start screaming. The team dives headfirst into the logs, but it's an absolute mess. They burn 15 agonizing minutes frantically searching through this sea of text and find nothing. With the pressure mounting, they've got no choice but to hit the big red panic button and roll the whole thing back.
And here is the night and day difference that good visibility makes. You see, before, the team was literally buried in a sea of unstructured text. It's like trying to find one specific word in a library full of novels. But after they switched to structured logs, a single clean query could have instantly pointed to the root cause, a simple misconfiguration. Problem solved in seconds.
And this is the superpower of structured logging. Instead of just writing out lines of plain text, you log your data in a consistent, machine-readable format, like JSON. It fundamentally transforms your logs from a simple diary into a powerful, queryable database. It lets you find the needle in the haystack in seconds, not hours.
Now, our final story is probably the most insidious one. It's about a ghost in the machine. I'm talking about a problem that was completely invisible to both metrics and logs, and it left the team absolutely baffled. I mean, this is a true nightmare scenario. The application is fundamentally broken for your users. They're seeing old, stale data from yesterday. But every single monitoring tool is glowing green. The servers are up, latency is fantastic, and there are 0 errors in the logs. The system is reporting perfect health, while the business is actually on fire. So here we are again, with the team stuck guessing. Was it a misconfigured cache setting? Maybe a delay in database replication? Could it be an issue with their CDN? They had no way of knowing, until they turned on distributed tracing. A single trace gave them the full picture, visualizing a request's entire journey across all their microservices, and it immediately pinpointed the one service that was failing to clear its local cache. And that is the absolute magic of distributed tracing. You know, in our modern world of microservices, a single user click can set off a chain reaction across dozens of different services. Tracing stitches that entire journey together end to end. It shows you exactly how all those services are interacting and, more importantly, where the breakdown is happening. It lets you see the whole story, not just a few isolated chapters.
So, this all leads to the crucial point, right? How do we avoid these 3 a.m. fire drills in the first place? Well, we take these painful, hard-won lessons and we build a playbook. A playbook to make sure we have the visibility we need before an incident happens, not during it. The fundamental thing here is a shift in mindset. We have to move away from being reactive firefighters, always waiting for the alarm to sound. Instead, we need to become proactive architects, building systems that are smart enough to tell us when they're about to break.
This checklist basically boils down all of those tough lessons into 4 actionable steps. First, monitor P99 latency for any external services you rely on to catch those hidden slowdowns. Second, use structured logs so you can query your way to an answer, not just guess. Third, adopt distributed tracing so you can see the full picture for your most important user flows. And finally, and this is a big one, make sure your alerts are actually tied to what the user is experiencing, not just some random system metric like high CPU.
And that brings us to our final thought. After hearing these stories, I want you to ask yourself this. What's the part of your system that keeps you up at night? What's the one potential problem that your current tools would completely and utterly miss? Answering that question, well, that's the first step to building a more observable and a much more resilient system.